Hello everyone. Dark matter is this unknown form of matter which accounts for about 85% of all the matter in the universe. But still we haven't got the slightest of clue about what it truly is. So can we expect dark matter planets or stars or life of dark matter to exist? Well, probably not. And to understand why, we need to first make sure we all are on the same page about what dark matter really is. Dark matter is a hypothetical form of matter that is needed to explain observations that show some gravitational anomalies. Like the gravity that we get by all of the normal matter present in the galaxies is not nearly enough to explain the huge speed of rotation of these galaxies. If the only matter present in the galaxies is the normal matter that we can see, the galaxies should disintegrate and should not be stable. We need more gravity in the galaxy to balance the effect of rotation. Something very similar is true for the speed of galaxies in galaxy clusters. The observed mass is just not enough. And the simplest way to fix all of this is to hypothesize a type of matter that only interacts gravitationally and by no other means. Therefore, we won't be able to see it as it would not interact with light as well, and therefore it will be invisible to us. And the only way we can observe it is through gravity. So it seems like dark matter really do exist. Now to answer our original question, we need to understand what dark matter can do and what it cannot. So let's first start off with some of the features and properties that we expect from dark matter. To begin, we expect or we think that most of it must be cold. And by cold we mean slow moving. We think that because if dark matter is not cold, i.e. slow moving, the smaller clumps of dark matter that are essential for the formation of structures of galaxies in the universe are just not possible. Here by clumps we mean concentration of dark matter as compared to other regions. Fast moving dark matter just can't form these small scale clumps. How the structure in the universe forms depends exclusively on how dark matter moves and clumps. And the model in which dark matter is cold builds a structure very similar to what we observe in the universe. It's not like dark matter can be fast moving, but it doesn't seem right that these would have had been in any large number. There are theories of warm dark matter and hot dark matter as well that correspond to dark matter with higher speeds respectively. But currently cold dark matter is generally accepted, as can be seen from the success of lambda CDM model of the universe in cosmology. CDM stands for cold dark matter. The model assumes dark matter to be cold and has been fairly successful in cosmology and has given accurate results that match observations. It is even called the standard model of cosmology for its immense success. Therefore, even though dark matter can move at any speed depending upon what it really is, it seems like most of it must be cold. Dark matter had affected the evolution of the universe and the structure of it in considerable ways. The clumps of dark matter we talked about are the reasons structures of galaxies in the universe formed. Dark matter is hugely responsible for the formation of many small and large scale structures of galaxies in the universe. Without dark matter, structures in this number would not have had been possible, and it's not hard to see why. The small disturbances in the distribution of matter after the Big Bang would have led some regions of space with higher matter concentration than others. This can also be seen from the cosmic microwave background. As the universe expands and cools, these regions would have attracted matter to clump, which would ultimately form the structures we see in the universe. These clumps were made hugely of dark matter, because dark matter is much more efficient in clumping than normal matter is. Why? Because there are no forces that resist the clumping in the case of dark matter. Dark matter only interacts gravitationally, therefore concentration of dark matter is easier to form. These clumps of dark matter then would have attracted normal matter via gravity, making it possible for the formation of galaxies. These clumps made mostly of dark matter constitute the cosmic web. So it's good that dark matter exists. Dark matter is seriously introverted. It does not interact with any force except gravity. This is why we can't see it, because it does not interact with light as well, which is electromagnetism. And we think that it does not interact with nuclear forces as well. So at the end of the day, we think that dark matter is a source of gravity we need to explain a lot of observations, and that it is very weakly interacting, and that it seems to be very cold or slow moving. Now, can dark matter really form objects like planets or stars? The answer, as I said, is probably not. And the reason is simple. Dark matter is very weakly interacting. It only interacts gravitationally, and we think that it does not interact any other way even with itself. We think that because we don't see the gravitational effect of dark matter as it would look like if there are large masses of dark matter floating around the universe, as we see stars and planets of regular matter. It usually appears as a halo of diffused gas in galaxies or between galaxies. The thing is that even though dark matter clumps, it's not the sort of clumping that is required to form objects like planets. Dark matter forms clumps, but it's more like tiny concentration of it rather than forming an entire object. The point is, it cannot stick to itself. What it forms looks like a diffused cloud of stuff. It cannot even touch anything, it just passes right through itself and any other normal matter. Normal matter clumps because of the electromagnetic interaction, which cools it down so that it can condense to form objects, but then there is no electromagnetism for dark matter. This is, for example, the image of the bullet cluster. Here the region in blue shows the region where dark matter is present. It became possible to map it because of its gravitational effect, mostly gravitational lensing. And the bullet cluster shows the collision of two galaxy clusters, and as you can see, dark matter just passes right through everything without leaving any interactions. So even though dark matter makes it possible for normal matter to form galaxies and stars, it cannot itself form any of these structures like stars or planets or like objects. Now for caution, I must tell you that we don't really understand dark matter completely. These conclusions are based on many assumptions about dark matter, so it can all turn out to be wrong and a mechanism might be found that allows dark matter to form objects. But whatever I've told is what looks to be the case currently. It's like it can turn out to be wrong with future advancement in science, but with our current observations, it looks to be the case that this is true and it cannot form structure. It's funny that we can talk about dark matter for hours, but in reality we have very little understanding about what it really is for certain. Thanks for watching, and I'm really glad that you watched the video till the end. Bye.